This video will explain how to reflect an object across a Cartesian plane. When you're reflecting, you'll be given a line of reflection across which to reflect your shape. It's always a really good idea to draw this onto your Cartesian plane to help you imagine how your shape will move. As a guide, if you are asked to reflect across the x-axis, your x-coordinate will remain the same, but your y-coordinate will change from positive to negative, or negative to positive. If I was to reflect this shape across the x-axis, the first point that I'm going to look at is point D. Now I can see that D is 2 and 2. It is going to stay on this x value of 2, but I'm going to count how far this point is away from the x-axis. So go 1, 2. That means on the other side of the x-axis, I'm going to have to count 1, 2. I'm going to plot this point, and that was D, so I'm going to be calling this one D prime. The next one I'm going to look at is point A. Now I have to do the exact same thing. It's going to stay within this value, but I'm going to have to count how far it is from that x-axis. So 1, 2, 3, 4, which means on the other side of the x-axis it's going to be 1, 2, 3, 4. And I'm going to plot that, and that was A prime. For B, it is still going to be on 6 for the x value, and 1, 2, 3, 4. 1, 2, 3, 4. So that is going to be B prime. And then for C, it is 1, 2 from the x-axis and 1, 2 on the other side of the x-axis. And that is C prime. Now I'm going to join all of these up. You would be joining them with a ruler. I've just reflected that shape directly across that x-axis. You can see that the distance above the axis is the same as the distance below it. These points here have not changed their x value because there has been no change in terms of x. If you are asked to reflect across the y-axis, then your y-coordinate will remain the same, but your x-coordinate will change from positive to negative or negative to positive. So C and D will remain on the same y value, and B and A will remain on the same y value as they go across. I'm going to look at D first. So I'm going to count how many spaces from the y-axis D is. 1, 2. So that means that on the other side of the y-axis, because I'm reflecting across the y-axis, it will have to go 1, 2 points. I will plot this here, and that was D, so I'm going to label this D prime. The next one I'm going to look at is C, and I'm going to count how far that is away from the y-axis. 1, 2, 3, 4, 5, 6, 7, which means that C prime is going to be 1, 2, 3, 4, 5, 6, 7. Plot that point, and that was C, so this is going to be C prime. Next one, A. So I am 1, 2, 3 away from the y-axis, so I will be 1, 2, 3 away on this side. I will plot that point, and I'm naming that A prime. Finally, looking at B, I am 1, 2, 3, 4, 5, 6 away from the y-axis, so I will be 1, 2, 3, 4, 5, 6 away from the y-axis on this side, and I'm naming that B prime. Again, I'm going to join all of these up. You're using a ruler to form the same shape, and you can see here that this is exactly the same distance away from the y-axis on both sides. Other ways you may be asked to reflect, it may not be directly across an axis. If you are asked to reflect across y equals 1, you will need to find 1 on the y-axis, which is just here, and draw a horizontal line through the 1 on the y-axis. So that would mean that you would be reflecting across this line. So C and D are only 1 space away from this line of reflection, so we would be finding our points around here. If you are asked to reflect across x equals 2, you will need to find the 2 on the x-axis, which is here, and you will need to draw a vertical line through the 2 on the x-axis. So in this case, you would be reflecting across this line, which would mean your D value wouldn't change here, and you'd just be moving that A to here to reflect that 1 point and 1 point. Then you'd be able to move those other points in the same way. If you're asked to reflect across y equals x, what this means is that the x and the y values of your shape will swap. So if your original coordinates were 3, 4, so x value of 3, y value of 4, the coordinates of your prime would be 4, 3. So an x value of 4 and a y value of 3. Your line of reflection will go from the bottom left of your Cartesian plane in quadrant 3, pass through the origin and travel up to the very right of your plane in quadrant 1. This would mean that in this case your d value wouldn't change, but your a value would become 4, 3. So that would be a prime. Your b value, which is currently 6, 4, would become 4, 6. Your c is currently 7, 2, so it will become 2, 7. And your d is remaining the same. So if I join these up, you will see that it is the same shape. It has just been reflected across that orange line, which is y equals x. And the opposite of this is if you are asked to reflect across a line of y equals negative x. In this case, your line of reflection will go from the top left of quadrant 2 right through to the origin to the very bottom of quadrant 4 in the right-hand corner. I'll get rid of some of this working. So if I was to reflect the original shape, ABCD, in the black across y equals negative x, my x and y values will swap places. So like they did with C prime in orange, that C moved to C prime across that line. Your x and y values will swap places and their signs will be swapped. My C equals 7, 2. B equals 6, 4. A equals 3, 4. And D equals 2, 2. This means that now, I'll pop it in black, C prime in this case is going to equal negative 2, negative 7. This is not a good place to write this, so I'm going to move this across to quadrant 4. So C prime equals negative 2, negative 7, because these have swapped places, and now they're both from positive to negative. B prime is going to be negative 4, negative 6. A prime is going to be negative 4, negative 3. And D prime is going to be negative 2, negative 2. Now, because I've got so much writing all over this, it may be hard to tell, but if I'm treating this as a completely separate transformation, then I can call this C prime. Just focus on what is in black. And we're focusing on the green and the black now. So I know that C prime, I'm just going to go with this one because I've got it here first. C prime is negative 2, negative 7. Now I really should go and put a negative 7 value in. I'm going to call this one C prime. You can tick that one off. Next, B prime, it is negative 4, then negative 6. You can tick that one off. A prime, negative 4, then negative 3. A prime, and then D prime is negative 2, negative 2. Joining these up, again you're going to be using a ruler. You can see that this shape, the original shape up here, A, B, C, D, has flipped across this green line, which is y equals negative x. Their x and y values have swapped places and their signs have swapped. In this video alone, you've seen a couple of different ways of reflecting. The most straightforward ways are reflecting across the axes, but if you're given an x or a y value, that is just as straightforward. It's just about finding where that value is. Remembering that y equals x and y equals negative x is just looking for that diagonal line going directly through that origin. The reflection values of y equals x and y equals negative x are a little bit more complicated, but once you start to understand the concept of what that reflection is actually asking you to do, it does make a little bit more sense. So keep practicing those, especially those y equals negative x and y equals x problems.